All right. In this section, we're going to study the method for using sample data from two independent samples to test hypothesis made about two population means or to construct the confidence interval estimate of the difference between two populations means. Okay, so section 5.1, we learned the methods for using sample data from the independent samples to test hypothesis made about two population proportions, and then to construct the confidence interval estimate, right, of the difference between two population proportions, right? So in this section, we're going to study the two. We're going to study about the hypothesis test and then confidence interval estimate for two population means. But first of all, we need to understand what's the meaning of independent sample and dependent sample. Okay, so excuse me. So now two samples you see here, two samples are independent, means that if they are not related or somehow paired or matched. Then dependent means that if two samples values are matched or paired, such as before, after, or husband and wife data. This is an example. So 36 subjects are weighted before and 6 months after being on the Atkinson diet program. So is that the samples what must be dependent, right? So this is dependent. And then the second example, 50 smokers and 50 non-smokers are given a memory test. So 50 smokers and 50 non-smokers, they are not paired or matched. So it should be independent. Okay. The IQ scores are obtained from 75 wives and their husband. So the husband and wife data, this must be dependent. The SAT math scores are obtained from 20 math majors and 20 biology majors. So math major, biology major students, they are you know, the not somehow pair or matched, right? So it should be independent. Yeah. So now I'm sure that you understand what's the how to determine the given samples, two samples, pair of samples, are independent, dependent. Now to figure out the answer for the hypothesis test for the two population mean, we need to first of all need to understand the terminology. I mean the notations of each of the sample statistics. Okay, so give me a second. So here, for population one, mu sub one is means the first population mean. Okay, and x1 bar is the sample mean of for the population one. Okay, sigma one means population standard deviation. But here we assume that we do not know the population standard deviation. But in reality, it's normally we do not know population standard deviation. So we assume that we don't know sigma one. Okay, S sub one is a sample standard deviation, and N sub one is size of the first sample. Okay, and then mu sub two is the population mean of the second population, right? And sigma two is a population deviation of second population or population number two. X sub two bar is the sample mean, I mean second sample mean. Okay, S sub two is a second sample standard deviation, and N sub two is the size of the second sample. Okay, so that these are applied to population two. Okay. Now next one, before figuring out the whether or not we can reject the null hypothesis in a hypothesis test, so we have to check these requirements. Okay, So let's see. The values of sigma 1, sigma 2 are unknown, and we do not assume that they are equal. Okay. The second requirement, two samples are independent, and then because this section we're gonna we gonna deal with the two samples which are independent, and then 9.3. Next section we're gonna study we're gonna deal with the two samples which are dependent. Okay. So anyway, this section we deal with the two samples which are independent. Both samples are simple random samples, and then either or both of these conditions are satisfied. The two sample sizes are both large, so that we can apply the central limit theorems, right? Or so that the samples are normal distributed, or both samples come from population having normal distributions. Okay, so now we learned how to figure out the answer for the hypothesis test. Okay. So here, first one, we assume that the null hypothesis A sub 0 is mu sub 1 equals mu sub 2. It means that there is two population means are equal. Okay, there is no difference. Okay, then H sub 1 going to be mu sub 1 is not equal to mu sub 2, right? Because H sub 1 must be opposite of H sub 0. So test statistic, we don't you don't use that formula, okay? But using the calculator, we're going to find out test statistic in a t distribution. The reason that we use a t distribution instead of the standard normal distribution, because since we do not know population deviations, so we have to use a t distribution. Okay, so now the df is degree of freedom must be smaller of n sub 1 minus 1 and n sub 2 minus 2 minus 1. But yeah, we just look at just look at it, but we do not use this. And then how much is difference between mu sub and mu sub 2? That's a question. Find the confidence interval estimate for mu1, mu2. Okay, so margin of error is formula right there, E, and the confidence interval must be x1 bar minus x2 bar minus E, and mu sub 1 minus mu sub 2, which is difference between two population means, is bounded by the difference between sample means minus E, and the sample difference between sample means plus E. Okay, so now using calculator, we figure out we can conclude that whether or not we can reject the null hypothesis, or we fail to reject null hypothesis, or in the confidence interval estimate, we can do that using calculator. So let me let me explain how to do it using by solving examples. Okay. All right, let's see example 1. In the PowerPoint slide, our male professors and female professors were rated differently by students. Let's see. Listed below are students' course evaluation scores for courses taught by female professors and male professors. A use of 0.05 significant level. This is ARPA, right? Significance level to test this claim that the two samples are from populations with the same mean. So now his claim is a null hypothesis, right? Mu sub 1 is equal to mu sub 2. Okay, so does there appear to be a difference in evaluation score of courses taught by female professors and male professors? Okay, let's figure out the answer for the questions. Okay, so first, what you're going to do, you need to enter these two data set in your calculator. Okay. The next one, we have to check those two data sets satisfy all the requirements. Okay, before going further. Okay, so first one, the values of two population standard deviations are not known. Yeah, the problem mentioned there, right? So they don't know the two population standard deviations, and then we are not making any assumptions on assumptions that they are equal. The second requirement, the two samples must be independent. Yes, independent. Those two data sets are not matched or paired in any way. And then third one, sample is a simple random sample. Yes. And then for both samples are small 30 or fewer, so we need to determine whether both samples come from populations having normal distribution. So we're gonna plot the normal quantile plot to check the those data are just normal distributed. Okay, so let's do this first. All right, so here calculator. So first one, I told you we need to enter the data, right? So, but I already entered the data, right? Say L18 and L19. So I already entered the two data set right there. So to plot the, let me plot the quantile plot. So we go to the stack plot, stack, and then we just turn on the plot one and then turn off all other plots. Okay, we enter the plot one, then we choose the last, in the type of the last one. And data list, L18, right? 18. Yeah. So now we see. Then we just press zoom and press number 9. Okay, so you see that here you see the all the data says approximately, I mean closely lies a straight line, right? So we can say that the sample data set 1 is normal distributed. And then we back to the stack plot again. Okay, and then we choose not L18 but second sample data set L19. Okay, with the press zoom, press number 9. So this is also, I know this last one is kind of out of the straight line, but roughly, I mean, closely we can say that the data lies in a straight line. So we can say that the second sample data set is normal distributed. Okay. So now what are you gonna do? And then once we check all the requirement, and then now we go to the test. To go to the test, we press stack. Okay, and then there is a test right there. Third tab right there. We use a 2 sample t-test. Okay, we don't use we cannot use a z-test. Okay, because I told you we do not know the population means, so we gotta use t-distribution. So we use a 2 sample t-test. Enter. Then there is a 2 way to there are 2 options. Okay, data and stack. If the problems give you the sample statistics, all the sample statistics instead of the data, you gotta choose this one, stack. Okay, right? So, but in example 1, the problems give us the data set, right, instead of the sample statistics. So we choose the data. And then list 1 L18, list 2 L19, which means that you just enter the list, the column name. Okay, list column name in here and here. Okay, and then leave the frequency 1 and 2 as 1. Okay, and then the next one we have choose H1. Okay, the alternative hypothesis, which is H mu sub 1 is not equal to mu sub 2, right? And the pooled means that in this one, pool means that 2 sample data are matched or paired. I mean dependent. Okay, but we'll deal with what? Independent samples, right? So we have choose no. Okay, and then we calculate. Or you can draw this. Either one just fine. Okay, but let me draw. Okay. All right, so now you see, we can see that test statistic is a minus 0.6599, and the p-value is a 0.5172, right? Okay, since p-value is greater than what, significance level, the problem says that significance level is a 0.05, right? So definitely p-value is greater than 0.05, so we fail to reject null hypothesis, right? Okay, so if you want to figure out more the numbers, then instead of choosing 0, we choose you choose calculate. So we go back to the two sample t-test, and then instead of the 0, but we choose calculate. Okay, so under that assumptions, mu sub 1 is equal mu sub 1 is equal to mu sub 2. Okay, that's h sub 0. We assume that h sub 0 null hypothesis is true. Okay, and then we got this t value is minus 0.659, okay, approximately minus 0.66, right? That's a test statistic. The Pbl 0.517. Degree of freedom is 19.06, approximately 19. And then x sub 1, x sub 2, these are sample means, right? And then x1, x2, these are sample standard deviations. Okay, and the n sub 1, n sub the sample sizes, right? Okay. Anyway, so since the p-value is greater than the sigmoid level alpha, we fail to reject null hypothesis. Okay, so let's move to the let's go back to the example 1. All right, so we can say that there is not sufficient evidence to warrant a rejection of the claim that female professors and male professors have the same mean course evaluation score. Okay, so that's the what's conclusion, okay, based on the sample data, right? And the next one, that's a Pbl method, and then we can figure out the conclusion about the hypothesis about the claim using the critical value method. Okay, so the since alpha is given, okay, and then the null hypothesis h sub 1 is mu sub 1 is not equal to mu sub 2, we apply two-tailed the method. Okay, so then we alpha over 2, which is 0.025. 0.025 must be area in the critical, the probability that we're gonna have significantly low, significantly high. Okay, the t value that to separate the significantly low and high, this one we can find out the we can find this t values, right? Okay, so now using the t value, using the table A3 in the textbook, or the you can find out this one. Give me a second. So in the calculator, you go to the state distribution right there, per second distribution. There is inverse t. This is how to find out t value given the probability. Because alpha over 2, half of the significance level, that's the probability, right? 0.025. We want to figure out the what's the t value corresponding that probability under the t distribution. Okay, so we choose the inverse t. Area is a 0.025, which is alpha over 2. Degree of freedom, degree of freedom, for degree of freedom, you have to choose a smaller degree of freedom of 2 sample sizes. Example 1, n sub 1 is 12, n sub 2 is 15, right? Then sample degree of freedom of first sample is 11, degree of freedom of second sample is 14, right? So now, anyway, you choose a smaller one, 11. Okay, we paste, then enter. They give you, this one give us the minus 2.20. And the problem, the using other technologies, that will provide plus, minus 2.093, what the PowerPoint says. Okay, but this is also acceptable. Okay, so, and then see, so here, we can figure out the test statistic, right? It's using the two sample t test. Okay, so since the t test statistic is greater than minus 2.093, so we fail to reject the null hypothesis. Okay, this critical value method, but this just you don't have to know both of them. Okay, I'm sure that you the Pbl method is more familiar than the critical value method, but I just introduced that one. Okay, so the if you deal with the problems for the hypothesis testing for two independent mean, the key mind is you're going to use the two sample t-test in the calculator. Okay, so let's back to the lecture note. So I told you, what if the problems give us the all the sample statistics, okay, instead of data, then use you fill in x1 bar, s1, n1, x2 bar, s2, n2. Okay, so keep in mind this. So pretty much you follow that the step, okay, to figure out the conclusion about how hypothesis testing for two independent means. Okay, what else counts as interval? So you see, two sample t interval. We use the two sample t intervals and then choose to input data from list such as L1, L2. Okay, all right. So now in our statistic enter, and then if you choose a statistic, fill in this one. You can come with the confidence level, and then you choose no for pool. If you choose data, fill in the list name and such as L1, L2, the type 1 for frequencies, and fill in the C level, and the pool choose no, choose calculate enter. Okay, so now let's see the data what we have seen example 1 to figure out the confidence interval. Okay. All right, see, example 2, confidence interval for female and male course evaluation scores. Using the previous data, construct a 95% confidence interval. So confidence level is 95%, right? Interval estimate of the difference between the mean course evaluation score for female professors and the mean course evaluation score for male professors. So right here, definitely you have to check all the requirement, but we did that in example 1, and then we use the same data. So let me skip it. So that's the formula of the margin of error. Okay, alpha is same as level, alpha is 0.05, right? Because confidence level is 95%, which means that alpha is 5%, which is 0.05, and degree of freedom must be 11, right? Okay, so now to figure out margin of error, you can use that formula, but let me use calculator to figure out margin of error. Okay, so keep in mind this: in the confidence interval for two independent samples, interval for the two independent samples mean, the mu1 minus mu2, which is the difference between two population mean, is bounded by the difference of sample means minus e, difference between two sample means plus e. Okay, keep in mind this. All right, now let's figure out the margin of error. I mean, the lower bound and upper bound of the difference between two sample population mean, okay, using calculator. So we go to the sample p interval, right? So we go to the stack, okay. So we go to test, and then see, you see a two sample t interval right there, okay. So we enter, and then we use the data, right? So L18, L19. Okay. So C level is not 99%, but 95%, which is 0.95, right? 0.95. Or just say 0.95. But either one just fine. The pool, we choose no, and then we calculate. So now you see that a second. Excuse me. So the rounding numbers, that we get this minus 0.53. I mean, mu1 minus mu2 is bounded by minus 0.93, minus 0.53 and 0.27. Okay, since that interval contains 0, right? So we can say that there is no big difference between two population means. It means that with a 95% confidence, So the minus 0.53 and 0.27, that interval, the confidence interval contains 0. So that confidence interval suggests that there is not significant difference between the mean course evaluation score for female professors and the mean course evaluation score for mean course evaluation score for male professors. Okay, so we can say that. All right, let's see one more problems. See this example in lecture note. Use a 0.05 significance level to test the claim that males and female have different mean body mass indices, BMI, right? So BMI is greater than 25 is overweight. BMI is less than greater than 30 is obese. So see, to mean instead of the sample data is given, instead of sample data, the sample statistics are given, right? So male BMI and the female BMI. Okay, so N is sample size and the X bar is sample mean. S is the sample standard deviation. Okay, so let's figure out the see whether or not we can reject the null hypothesis, or we can accept the null. We fail to reject the null hypothesis. Okay, what's the null here? Null hypothesis. So there the female, male and female BMIs are equal. That's the null hypothesis, right? So let's see. So we go to the stack and then test. Then we see we use a two sample t-test. Okay. So now we choose stack as input. Okay. All right. So X bar must be X1 bar. This is sample. I mean, male BMI sample mean, right, which is 28.44. Then male BMI sample standard deviation is 7.39. N1, 40. And then X2 bar, which is the 26.60. And then 10% deviation is 5.36. And 2, that's the 40. Okay. And then H1, I mean, alternative hypothesis is what mu1 is not equal to mu2. And the pooled, no. Okay, then we calculate. So test statistic is 1.2727. Okay, you see the p value is 0.206. Okay, here the alpha is a 0.05, right? So definitely p value is greater than 0.05. Okay, so p value is 0.206, which is greater than alpha, which is significance level 0.05. So we fail to reject the null hypothesis, since null hypothesis is a claim, right? So there is not sufficient evidence to reject the claim. The male and female have different mean BMI. Okay, that's the conclusion. Let's figure out the confidence interval. Okay, so actually this is the second question. Find the 95% confidence interval estimate for mu1 and mu2. Well, let's figure out the 95 confidence interval. Okay, so we go to the step, test, and then we choose the two sample t-test. Okay, so here's a step right there. So we use the same sample statistics. Okay, so C level is 95%. Yes, can you calculate? So see that here we got the confidence interval minus 1.038 and the 4.7181. So you need to fully understand what does those two numbers means. I told you the left number is what? X1 bar minus X2 bar minus E marginal of error. And then the right number is X1 bar minus X2 bar plus E marginal of error. Okay. So that's the all about what population mean, two population mean, okay, independent for two independent samples. Okay, so next time I'm going to cover 9.3. Let me stop here.